Hello and welcome back to the Blade of Akai channel. You are watching Shenzhen IO. In the last episode we kind of completed a light up sign and a pulse generator, and now it's on to newer things. Rubbish audio thing. Okay. So Carl is saying, so a contract comes in to build a piece of audio kit. Sounds fun, right? I've always liked audio. This client promises that their little box will deliver crisp highs and booming lows in all in perfect balance. Then I see their advert happens to include the much vaunted algorithm that powers this thing. Go on, take a look yourself. Should I mention I put a copy of said advert on your desk? Just look in the pile of papers marked supplemental data, since that seemed most appropriate. I should also mention that we still have to do this, as sad as it is. Work's work and all. Even when you have to help a dodgy American company market rubbish like this as premium kit for audio files. It's probably synonymous with what actually goes on in industry. So it's hinting that I need to look at the supplemental data. Perhaps if I open this, it might give me a better hint as to where I'm looking. Harmonic maximization algorithm. So I need to find this in the documentation. Audio in is a simple input connected to an audio source. Audio out is a simple output connected to an audio receiver. Maximize is a simple input connected to a switch. The signal from audio in should be copied to audio out, applying the harmonic maximization algorithm when the maximize switch is on. Look in the supplemental data section for to find an advertisement featuring harmonic maximization algorithm. Okay, I'm trying to find it. There's all sorts of stuff here. I do need a ring binder. No, this is just kit. I think I'm in the wrong part here. Here we go. Audio out equals audio in minus 50 times 4 plus 50. Minus 50 times 4 plus 50. Okay. Seems pretty straightforward. Right, let's keep that page open a minute. Right. So, I don't know that we need anything wonderful, so let's just use the MC4000 like we have been to date. Maximize. Can I put no? Okay, that's interesting. What about this? That's, see, this has only got 2 inputs and outputs, so I'm gonna have to have 2 things, it seems. So I'm gonna have to do this, which will in turn I can use, well, when this is like gone high, I can use it as an input to this somehow. Now, audio in's gonna have to go into P0, pretty sure. I might have to move that over, and I think I don't know that I need to use a signal. I think I can just use No, I do need to use a signal there. I'm being silly. Right. Okay. And then audio out. So I can say... Right, yeah, okay. So I can say... move P0 X1 maybe. Let's have a look at the verification tab. So I shouldn't have control over this, right? This should be just coming in, and so should this. Okay, and this is what we're trying to achieve down the bottom here. So these are inputs that we don't have any control over. This is the output. Right. Okay. Right. So, test equal to, I guess, 100. Test equal x0 100. If so, if that's the case, we need to apply this algorithm. So we need to say, well, actually, before all of that, we need to say move. When I can type, move P0 into the accumulator. Okay, and then once we know that the switch is on, we can then say accumulator. I need my arithmetic operators now. Add sub mul. Okay, so we want to right, I need to remember, because the algorithm says, or the equation or formula says, brackets audio in -50 close brackets times 4 plus 50. Now PEMDAS says we do powers, exponential, multiplication, division, then addition and subtraction. So that means that the audio in -50 times by 4 happens before the plus 50 at the end. So it's going to be sub ac 50. What? Oh, I don't need to specify the thing. So sub 50, then mul 4, and then at the end add 50. Okay. Oops, and I forgot my plus operator. Okay, and then if it's not, what are we going to do? We don't need to do anything. In either case, we need to move AC to P1. Right. And then what? Can we just sleep 1? Sleep 1? Is that going to work for us? First time. Awesome. Wow. I was expecting to have a little bit more work on my hands with this one, but did it first time. Okay, so yeah, so I did it like pretty much most people. I'm not sure how we're getting this power usage down. Production cost. How did they manage that? How does that work? So I don't know what the currency is. I can't remember. I know what the Japanese one is. I don't know the Chinese or the Hong Kong thing is. But how I don't know how they've done this. So, you know, in the very least, from what I could tell, you needed 2 of these things. So if you needed 2, how do you come in with a cost that is less than 6? That doesn't make any sense to me. There's some cheating going on here. Unless people are going back when they've got upgraded kit. Maybe that's what's going on. I don't know. Holy crap, this thing is awesome. I hooked one of these babies up to my stereo at home and it blew the speakers clear off. Does the job, no question. Amazing. Okay. Right, what's this? Self-driving car stuck in a loop. You may be entitled to a settlement. Dear consumer, if you bought a self-driving car in the past 5 years and your car was involved in a rogue loop incident, you may be entitled to compensation under a settlement to a class action lawsuit filed in the US District Court for the Southern District of California. A rogue loop is defined by the court as a state where a self-driving car appears to disregard humans and continues to drive around, refueling itself when necessary and in ignoring orders to stop. If you believe your self-driving car has experienced this condition in the last 5 years, please contact us for more information on how to submit a claim. The law offices of Stead and Holman. Attorney rogue loop claims. Attention rogue loop claims. Okay. So we got rogue cars. I reckon we're going to have to fix one. Right? We're going to have to make a circuit to fix one at some point, maybe. Maybe we'll do, because there was something about orbital selfies here, maybe we'll do something to do with space programs as well. I don't know. So we're going to look at this next one. Bring out the Baron. So Joe is saying, the Baron von Schnaps is in the house, y'all. I was out drinking last night and met someone from the company that owns this brand. There's a drinking game they're promoting that's hella fun and off the rails. I made a deal to supply them with little personal scorekeepers they can give away at their events. Carl saying, wait, what? What's the game? What counts as a point? What would be a foul? Surely not individual drinks. I don't remember the actual rules. Okay. Well, how can I design against something he doesn't know the rules of? Open design. Okay. He's got some rules now. Point and foul are simple inputs connected to buttons. Okay. Display is an X-bus output connected to a numerical display. So we can use one of the X ports. Okay. The counter should keep track of a count starting at 0 and constantly update display with the current value. When point transitions from low to high, the count should be incremented. When foul transitions from low to high, the count should be decremented. Okay. Okay. Alright, so we're going to need two devices for the inputs. Right. Hang on a minute, let's just check. Simple inputs. Yeah, we can't use X-bus. Right, so we're going to need one here. And we're going to need one here. I'm going to have to think out loud a little bit here. So if I did test equal P0 and ACK, there would be no state change. Okay. If there is no state change, if that's false, then what I want to do is move P0 to ACK, and in that case I want to move 1 to x1, maybe, and then if I put this over here, maybe, let me think about this, and then over here test equal P0 ACK. So we've got the same thing again. Move P0 to ACK. No. What I want to do is sub. Right? For each input on the file, I want to sub. In fact, I don't need to do a move operation there. I can just do add ACK. No, I don't want to add ACK. Add 1, sub 1. Okay. So this is keeping the positive score. This is keeping the negative score. And then basically on the output, oh, see, that's not going to work. Okay, I think I am going to have to use one of these bad boys. So let's get rid of all of this a minute. Let's move. I'm going to have to move this over a tad. Okay, this is going to have to, let's get rid of that a little bit. This is going to have to go here. This is going to have to go there. That's going to have to go into there. And then I'm going to have to do the same here. So tech P0 ACK. If that's not true, which means there's been... Oh, hang on a minute. I need to do the alternate. So plus move P0 to ACK. Oh no, see that there's a flaw in the logic. So yeah, so if there's been a change, test equal ACK 100. Yeah, test if the accumulator is 100. No, test if P0 is 100, not the accumulator. That's better, right? So over here, test ACK, so minus tech, right, P0 100. So if that's gone high, again, no, this one is sub 1, then move, then no. Right, I can't do it that way. I think this sounds crap, but maybe I'm just not very good at this, but I think I'm gonna need, and let's get rid of that, I think I'm gonna need 2 of these things. Oh, it's not asynchronous. Why? Why isn't it asynchronous? That makes things so difficult. Right, I actually have to implement the whole lot, really, otherwise I'm going to have to write half a bunch of code just to mimic what's going on in the first board. just to verify it. I might even need 3 boards. This is ridiculous. Okay, I think I need 3 boards. But however, 2 of them can be these, I think. So I need to rewrite. Can I just copy and paste all of this? Copy, paste, yeah. And I can get rid of that. Put this over here, yeah. And put another one down. Paste that in there again. Let's get rid of that for a minute. Put that there. So both of these are individually understanding whether or not the button's been pressed, and that is a state transition or not. That's got to change to X1. X1. Oops. 12. Right. So that's X1. And that needs to be just AC, I think. AC. Right. Do the same up here. AC. And then here. So now we just got to hook up the X1s. And I'm going to need 2 inputs. And this is where the MC6000 comes in. Right? So I need to go from there to there and there to there. Actually, do I need that bit? Because the accumulator can keep that as a running total. I think I might be able to get... Oh no, because I need 2 inputs. I mean, I could do P1 to P0 and instead of saying X1 here and X1 there, use P. But I think that takes more power. I'm not sure. Sod it, I'll do it like that, and then that's got to go out there, I think. And then, so we need to change this to P1. Now, right, we've got, is it 1, 2, 3, 4, or 1, 2, 3, 4, then sleep. So if I do so for each thing we have to do add x0 sub p0 nop sleep 1. Nop is no operation, which means that we're in sync, and these work the same way. I hope this works. I don't have much hope actually, but yeah, part not sleeping. Okay. Oh, and I'm not actually I'm not actually even moving. X2. What? Move act to X2. Right. I wasn't even outputting. Right. Ding. 0. Yeah. Sleep. 0. Sleep. 1. 0. Sleep. And that's where it's falling over. Okay, There's a sleep X command. If I can, hang on a minute, because on the quick reference card it's saying SLX and then P, which is a pin register. But surely if you're doing SLX, you want it to do it on a signal, which is off the X bus. X bus. So in another piece of the documentation, it's saying that SLX X0 is a command. I wonder if I can do this. Let's put this in and get rid of this. Get rid of all of that. We're gonna have. Hang on a minute. Which one's X? That's the one. Let's do that. So X1's going to go out that way, and then can we do that? So we can bridge the two. Can we? Can I do that? Is that valid? And then sleep X0. And then ACK, and then add X0, which could be a negative number. Move X, move ACK to X1. Heart not sleeping. I've got to put those back. Right, sleep 1. Sleep 1. These two are going to be synchronized, right? So oh well, kinda. We're kinda getting some success here. What's going wrong then? Yeah, see the stuff is being sent. That's why we're getting this. It's being sent faster than it's expecting it to be there. Okay, I've revised my logic a little bit, and actually we've saved some lines as well. But basically, what I'm going to do first is test to see whether whether P0 is equal to the accumulator, right? If it's the same, there's been no change. Right, if that's the case, we need to send a signal of 0. Okay? Otherwise, we want to check. Otherwise, we want to move the changed value into the accumulator. So if P0 goes from 0 to 100, we want to store 100 in the accumulator. Okay? After that, we want to then test to see whether the accumulator is at 100. If it is, then we need to move the value of 1 into X1, then sleep. That should be everything. That should be the entire logic. Now I need to copy this down here, but bearing in mind, before I finish, I need to change this value to -1. Okay? Hopefully, we're going to see a little bit more success on this. Hopefully, fingers crossed. Where's the uninstall button? Oh, okay, so something's not quite right with my logic. Right, I think I need a label now. Right, 2 signals sent, both 0, jump to end, sleep. Yeah, both 0 again. What's going on here? Can you not blooming test things now? What's going wrong? Okay, it's starting to take shape. The values are right. That should be a 6 there, but it's not getting anything. But something is going wrong at the transition point. So what is going wrong? If it's not, we need to move 0 to X1. Not plus, minus. This is starting to get more complicated again. Move 0 to x1. So, right, step. So this is P0 is equal, right? Okay, fair enough. That's right. So that one should send 0. This one is not equal, so it should be moving P0 into ACK, which is a transition. So then it should be testing to see whether the accumulator is 100, which it isn't, and therefore should be sending 0, which it does. And then they both sleep. Yes. Okay, now the top one we should see it pass through basically down to sleep, but the second one down we should also see it do the same, really. Oh no, that's where it changes, isn't it? Okay, so now the ACK is 100, which it is, so now it moves neg1, sleep. I don't believe it. I've done it. I've done it. It creates a different set of data, look, each time. Finally done it. I'm just gonna go and cry myself to sleep now. Oh my god. So we cost ourselves 9 dong or whatever it is. I don't know what the Hong Kong currency is / Chinese currency. Power usage was pretty average, but looking at the graph, it looks like I could have done a lot better than I have. But I'm not very good at this, so there you go. I'm better with third, fourth generation languages than low level stuff, obviously. Return to email. Okay, oh, hang on, let's read I don't remember the actual rules. If you can't remember the rules of the game you were playing, how sure are you actually made the deal? Because they sent us a case with a variety of flavours. It's very tasty stuff. Come and try some. It's already too late for me, but you can still save yourselves. Heed my warning. Do not drink the Baron von Schnapps. Bye then. See you in the next life. So apparently it's quite bad. Okay, I didn't want to be beaten so badly by the poor design, and instead I've managed to come up with a single board use design. The code is quite a bit more complicated than the split board design, but effectively I'm using an MC6000 and I'm throwing the point button into P1 and the foul button into P0, and then I'm outputting the XBus X3 to the display. And effectively what I'm doing is I'm checking to see if I'm checking to see if pin 0 is equal to the value in DAT. Okay, if it's because I'm using TCP, this is a special kind of operator. So basically, if A is greater than B, plus instructions are enabled. If A is equal to B, no operations are enabled. And if A is less than B, only negative operations are enabled. Okay, so it's a bit kind of fiddly getting your head around it. But essentially, if P0 is greater than DAT, these operations are enabled, and when they are, it allows me to subtract 1 from the accumulator, which is the scorekeeping element, and then jump to high. And what high does is it it sets the value of 100 on DAT. And then it goes from there to end, and then which is basically moving the signal in to X3, and then sleeps for 1. Now, it will then basically stop. So the limitation on this board is that it can only accept an input from 1 pin at a time. Now, given the test data, and I've run this through the tests and it passes, the test never overlaps the signal. Okay, so you're only ever pressing one button or another, and there's always a gap between the two. Okay, so given that, this board works. In real life, you wouldn't do it this way. Not unless you expect it to just, fall over in a heap when you press both buttons at the same time. So basically, that's the subtract bit, and then the addition bit is if P0 is 0 and DAT is 0, it then falls through to TCP P1 DAT, which is P1 comparable to DAT. And if P1 is greater than DAT, it then performs these operations, which is adding 1 to the accumulator and then jumping to high to set the DAT to high. If it's not that, it will pass through to the next element. And the next element is basically saying, is P0 equal to P1? Okay? If they are, it means they're both off. And if they're both off, we need to reset. So we can then say reset, which gives us this move 0 to DAT, and then jump to end, and jump to end will move whatever's in the accumulator out to the display, and then sleep again. And this works, and because it works, it's now given me an end result which is using a lot less power, because I think I was into something like 600 odd before, and now I'm down at 437, and I'm only spending 5 whatever this is. Now, there have been people that have managed to get better scores than these. I don't know how they're doing it. I really don't. There must be something you unlock later that you can use to go back and make these again. But yeah, there you go. So I managed to improve the design by using one part, a bit more complicated logic, and made some basic assumptions about the test data and how the thing is going to operate. So yeah, I'm going to leave this episode here after that mammoth effort. I hope you liked it. If you did, don't forget to hit like, share and subscribe, and I shall see you all in the next video of Shenzhen IO. Thanks for watching, and bye bye for now. Human hack. What? What the hell?